Okay, page 97 stroke 8 cumulative frequency diagrams. If you have some data in a grouped data form, having different classes with a frequency within each class, you can actually work out mode, median, mean and range directly from the table. But if you plot a cumulative frequency diagram, you can get a very accurate estimate for the median of a set of data, and also you can work out the quartiles of the data, and from the quartiles you can work out the interquartile range. Now I'll talk about it in detail as we begin to do it, and that's the phone gone again, but we'll ignore that. First things first, page 98, question 3a. Use the diagram to work out the median. Well, of 100 gerbils, got 100 gerbils there, we can find the median, which is gerbil number 50. So hit the 50, draw along. Oh, it's not very good, is it? So hit the 50 there, draw along, hit the line, and then come back down again. Yeah, sort of make that 4.2. So the median, change to pen, equals 4.2 ounces. Is that alright? That's the median, and that's question A. I didn't draw that very straight, so sorry there. You can see from 50 straight across, should be about there really, then read straight down, and that's good enough with the accuracy that I've got. Next one, the lower quartile. Well, the lower quartile, I've got 100 gerbils, a quarter of them is going to be 25, so I'm going to hit that again on the 25, thereabouts, hit the line, and then come straight down. Now, I read that as 3.6, so here I go, lower quartile. .6 ounces, symbol OZ. Then it says the upper quartile, so that's on the 75 mark, because 3/4 of 100 is 75. So I land it about there, come over, hit the line. Very hard to control this, you know, really hard. Straight down. Right, that's going to be 4.8 upper quartile. Um, 4.8 OZ for ounces. Then it says the interquartile range. I want to change colour here. Now the interquartile range, here we go. That's going to be the upper quartile, take away the lower quartile. So what do we got then? We got 4.8, take away 3.6, that looks like 1.2 ounces to me. Now, let me just talk about this. In calculating the interquartile range, we're actually calculating a range or a spread. So I'll put this here, a measure of spread. Just like with this, the ordinary range, biggest takeaway, smallest, is a measure of how spread out the results are. Now, with biggest takeaway, smallest, that's quite a low level piece of analysis. With the interquartile range, we're looking at avoiding the bottom quarter of these weights and avoiding the top quarter of these weights. Therefore, we're just focusing on the middle half of the results between there and there. Do you see? And as you can see, half the weights of these gerbils are within a very tight range indeed. So really, that's a great way of analysing the spread of results in groups when read off a cumulative frequency diagram. It avoids the extremes of the bottoms, it avoids the extremes of the tops, it's focusing on what's happening in the middle half of the population. And the comment on the 1.2 ounces has got to be, it's a very narrow spread of weights for the middle 50% of the sample of the 100 gerbils there. Right? That's the sample we've taken, and that's the graph ready made. Interquartile range, therefore, a measure of spread focusing on the middle 50% of a population. So that's the IQR, interquartile range. Next one, it says use the diagram to find the percentage of gerbils who are under 2 ounces. And it's going to be quite hard to read that. Under 2 ounces, well, 2 ounces is that. If you read across there, these little squares go up in 2, so therefore I think it's about 2 across there, ever so carefully. So I see that we've got 1 square only, so that's 2 gerbils. So 2% happen to be under 2 ounces. Alright? we can use it quite easily to calculate 2%, because really we've got 100 gerbils, so every single one of the markings stands for the percent that it says. So 60 is actually 60%, as it turns out. We've got to find the percentage gerbils who are over 5.5 ounces. 5.5 ounces is there. Better use a line. So 5.5. Hit it there. Plant it about there, I think. Then come over here like that. Now, from my very crude diagram, I can see that from 90% onwards, I've got 10 gerbils who have a weight over 5.5. So reading up 5.5, turn left, and that's 90% of the gerbils. So back to my green pen. So, sorry, not 90%. Oh dear. If 90% is where we read off from 5.5, and I've got 10 left up here in this region. So here we go. So 10% are over 5.5 ounces. Okay, so I've done that a little bit sloppily there, I'm sorry. I want to carry on. There's other questions. Right, look at this one. This is taken from Summer on Earth. Yes, question 4. It's really lovely. Look, we've got a ready-made group data table. Let me just talk you through it a little bit. A ready-made group data table. We've got the frequency distribution of the lifetimes of 1,000 light bulbs in hours. So we've got 50 to 100, 80 of them, 100 to 150 hours worth of lifetime, 240, etc. Now look how cumulative frequency was calculated. It's really a running total. So if I write the word running total here, then that'll give you an idea in common speech of what a cumulative frequency actually is. It's a running total. So the first 80 are there. Then I said 80 plus the 240 there. So add the 80 on, gives us 320. Then we're going to add on 320 onto the 390. Okay, that's how we get 710. We're going to add the 710 onto the 200. Brings us up to 910. Add the 910 onto the remaining 90 bulbs. That gives 1,000. That's where that comes from. That's grade B alone. That. Right, copy and complete the diagram. We've done that. Draw the cumulative frequency diagram and use your diagram to do X, Y, and Z. Alright. Already done. Okay, what I've done, it's really important that you note this. Go back another page. I have used the upper bound of each class. So as I said before, under frequency polygons, this grouping is called a class, just to remind you. And that's the lower bound of the class, and that's the upper bound of the class. You always use the upper bound of the class when plotting cumulative frequency diagrams. Therefore, you need to plot this and obviously the cumulative frequency that we're plotting. So this goes along the y-axis vertically, this goes along the x-axis horizontally, and that's what the graph shows. Let's study it again. Okay, 0 to 1,000 bulbs, cumulative frequency, 0 to 300 hours worth of lifetime. Go back again, let's take a look. It says, let's find the median. Alright, let's go and do that. Find the median, and we've got 1,000 items here, so I'm going to read off from 500, hit the line, come down. So the median bulb has a lifetime use of 175 hours. So maybe I can write it here, can I? Hopefully it will fit here. Median equals 175 hours. Now of course, if you plot your own graph and it's slightly out and your line isn't perfect, like mine isn't, you might get slightly different answer, but there's permissible ranges of answers that examiners will accept. Right, lower quartile, upper quartile. Okay then. Lower quartile, well, a quarter of 1,000 is 250. So let's just read that off. And the lower quartile is right here where I'm pointing now. So let's just change to that. Let's call it LQ just to speed things up. Lower quartile, we've got, what have we got here? 100 and 125, 130, also about 135. Okay, 135 hours. Let's find the upper quartile, which is bulb number 750. Take it to my line, read down. Yeah, 210. Yeah, I accept that. So the upper quartile is 210 hours. What do they want us to work out now? Okay, the interquartile range, IQR, let's just do that straight away. The IQR, you remember, that was the upper quartile, take away the lower quartile. So we've got 210 hours, take away 135, that's going to be 75 hours. Alright, so the spread of, how does it say now? The spread of lifetimes of these 1,000 bulbs for the middle half of them is 75 hours. Look what we've done. We've avoided the bottom quarter, and we've avoided the top quarter. We've focused on the middle half in the just there, and it's quite a tight spread, isn't it? So we have a spread of 75 hours for the middle half of the sample taken. Right, next little bit. What's it say? Oh, next question. Let's go back. It says, estimate the percentage of light bulbs lasting beyond 1 week of continuous use. Okay, so I've got 1 week. Well, we've got this in hours, haven't we? So a week is going to be, we have 24 hours a day, and we have 7 days a week, assuming these light bulbs are on the weekend. So continuous use, I've got 24 times 7. I'm looking at the number of bulbs who can live longer than that many hours. Let's just get the reading of that very carefully. Estimate the percentage of light bulbs lasting beyond 160 hours of continuous use. Right, 168. Let's go red on that because it's going to be, I want it to stand out. 168. Again, it's really hard to read. 150, 200, 175. So let's take a real good look. Now I'm going to plant it about there. Take it as far as I can. Hit my line. Just study that. That's more like 170. That's the best you can do on this scale, and that's fine in an exam. You know, you've got to work with what you've got. Let's just turn left. Right, read it right there. Back to the pen. Right, study it carefully. Read that number. That is 440. Well, I want to know how many lasted longer than 440. So let's just do a quick sum. 1,000 of them. Take away 440. Gives us 560. Change that into a percentage. So 560 out of the original 1,000 times 100 will give us something. Doing, 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 doing. It looks like 56%, doesn't it? And look, count those zeros. Yes. So 56% of the bulbs lasted longer than 168 hours, because we're looking at all these bulbs up here that have exceeded the 168 just there. Is there anything else to say? Explain why your answers to C are estimates. Very simple. Do this all the time. Why are all these answers estimates? Answer, I've got 1,000 bulbs and we do not know the lifetimes of each individual bulb. All the data is given to us in groups, therefore we can only estimate all these different measures from a graph.